Today we're going to talk about making equivalent fractions and also rounding decimals. But the first thing we're going to discuss is equivalent fractions. So when first writing that term, the first person that popped into my mind that would use equivalent fractions, other than a math teacher, would be a real estate person. And I'll show you what I'm talking about. So let's say they just come across a large piece of property, a large lot, and they are looking to sell it. Now they could sell this whole entire lot, or they could break it up into parts and sell individually to try to make more money. So let's look at one option that they could do. They could take the same big lot and break it up into two sections, which probably be an easier sell. So let's look at this part that is sold, and let's write a fraction that would illustrate what is sold. All right, so we've got one part sold out of two parts of the original lot. So we have a fraction of 1/2 representing what is sold from the lot. Let's look at another option. What about option number 2? They could divide it up into even smaller lots. And so let's see here, 1, 2, 3, 4, 5, 6. So we've got 6 parts here, and how many are sold? 3. So we've got 3 parts sold out of the 6 lots. Now, both of these fractions, 1/2 and 3/6, are representative of equivalent fractions. Equivalent fractions definition down here. So we got 1/2 and we had 3/6. So looking at the definition down here with equivalent fractions, it says equivalent fractions, fractions that represent the same thing but are written differently. And that's exactly what we have here. 1/2 and 3/6 both represented the same amount of space pertaining to the lots. Now, one way you can check it is you can cross multiply, check their cross products, if you will. 2 times 3 is 6, and 1 times 6 is 6. So they both mean the same thing. Now, some of you are already seeing that 3/6, you could reduce that down and get 1/2. So there's a couple of ways that you can check to see if they are equivalent fractions. But fractions that represent the same thing but are written differently. Okay, so this is my question. Could we make an equivalent fraction with a specific criteria? Can we make a specific or make an equivalent fraction with a specific criteria? Check this one out here. Example, given 2/5, make an equivalent fraction with the denominator of 20. The denominator of 20. This is what you're starting with, 2/5, and you want to make a fraction with the denominator of 20. Okay, let's recap for a second. The numerator is the number on top, and the denominator is the number on bottom. Chicken scratch right there. Numerator is the number on top, denominator is the number on bottom. Okay, so let's go back. What are we going to do? We're starting with 2/5, and we want an equivalent fraction that has a denominator of 20. That's my specific criteria. What do we need to do? Let's look at these steps over here. Step 1, how many times does your denominator, which is right here, divide into the new denominator? So how many times does it divide into this denominator here? Well, I think you guys would all agree that 5 will go into 20 4 times. Now what do you do? Step 2, take that number, which was here, and multiply it by your numerator, the one that you had. 4 times 2 is 8. So what do we do with this 8? Step 3 says the following answer should be written as the new numerator. There is our equivalent fraction. All right, let's go again. Given 3/7, so this is what I'm giving you, make an equivalent fraction for a denominator of 56. This is where I want us to go. All right, so we have 3/7, and I'm wanting to make an equivalent fraction equal to with a denominator of 56. Let's go through the steps again. Step 1, how many times does your denominator divide into the new denominator that you want? How many times does it divide into? 7 will go into 56 8 times. All right, step 2. Take that number and multiply it by your numerator that you already had. And 8 times 3 is 24. What do we do with that? Step 3 says the following answer should be written as the new numerator. So that 24 goes right here, and this is our equivalent fraction. Remember, equivalent fractions are fractions that mean the same thing, that represent the same thing, but are just written differently. Okay, what about you? If I've given you 7/8, make an equivalent fraction with the denominator of 32. Go ahead and pause the video, try that, and then click play when you have your answer. All right, did you come out with 28 over 32 being your equivalent fraction? I hope you did. If you didn't, let's talk about it. You started out with 7/8 and you needed a denominator of 32. So first step, how many times does your denominator go into the denominator that you want? 8 will go into 32 4 times. Then you take that number and multiply it by the numerator that you had. So 4 times 7 is 28. This is your new numerator. Goes over that, and so we have 28 over 32. All right, let's talk about rounding decimals before we're done here. All right, so rounding decimals, first let's label them. So I put 1.2345. Now I didn't label the 1 because all decimal places are the places after the decimal. So 1 place from the decimal is the tenths. 2 places from the decimal is the hundredths. 3 places from the decimal, going to the right, is the thousandths. And the 4th place, going to the right from the decimal, is the 10 thousandths. Now it goes on and on, but we're going to stop right here. So whatever place that you're rounding to depends on the number to the right of it. Whatever number or whatever place you're rounding to depends on the number to the right of that place. So let's look at a particular problem. Example, round 1.2345, the same number that we used here, to the nearest tenths. So you can go back up here and look. The nearest tenths, that would be 1 decimal place to the right of that decimal. 1 place to the right of that decimal. So where do we need to look? We need to look to the right of that number. This is the number we care about. So it's kind of like the 10th place is saying this. 5 and above, give me a shove. Or 4 and below, keep me down low. So my question to you is the number 3, is that 5 or higher? Hope you said no, and you're exactly right. So we're not going to give this 2 a shove and bump it up. We're going to keep it down low exactly where it is. So my answer for this would be 1.2. Doesn't go anywhere else. Let's do one more. Round 1.2345 to the nearest thousandths. All right, so the thousandths would be the 3rd place. Tenths, hundredths, thousandths. So this is what we're looking at. But we've got to look to the number to the right of it. And we ask ourselves, 5 and above, give me a shove. Or 4 and below, keep me down low. Is it 5 or above? You got it. So no longer is this going to be a 4. We're going to round it to the next number up. So your answer is 1.235 is the answer. The 4 has now become a 5, and you drop the rest of the decimal places. So we've done equivalent fractions, and we've done rounding decimals. Let's get going with some work. See you in class.